Dear students, here we will talk about the ultraviolet region of electromagnetic spectrum. As we know that the UV radiations are of high energy and their wavelength can be computed as from the Planck's equation, that is E is equal to h nu, which is frequency, and nu is equal to c over lambda, where lambda is the wavelength. Here we will categorize ultraviolet radiations according to their respective wavelength and their respective energy, we can say. When studying UV visible spectroscopy, UV region is mainly divided into two regions or wavelength regions. One is known as vacuum region, which is from 10 nanometer of wavelength to 200 nanometers, shorter wavelength of higher energy. Vacuum region because you cannot study the spectra or quantification of a compound unless you create vacuum to analyze that very sample. The reason is that the atmospheric gases like nitrogen, oxygen, carbon dioxide, water vapors, they absorb in that very region from like 10 nanometer to 200 nanometer, and most of the sigma to sigma star transitions of molecules, they also occur in the vacuum region, like 160, 170, 180 nanometers. So vacuum region practically cannot be studied, or you cannot study different analytes or characterize them or quantify them in this very region until you have a vacuum atmosphere, because natural gases and water vapors will interfere in the spectra and quantification of the compounds. So these transitions, like sigma to sigma star transitions, are not generally studied in UV visible spectroscopy because of the fact that they lie in the vacuum region. Second region is quartz region, that starts from 200 nanometer wavelength to 400 nanometer, and that's the region which is generally used, the wavelength range that is generally used to study most of the organic molecules as well as metalline. Quartz is actually ordered silica, and the samples, liquid samples, are placed in ordered silica cells or cuvettes or sample holders when they are analyzed in the UV spectrophotometer. And silica is transparent to this region, means silica will not absorb from 200 nanometer to 400 nanometer. It will not absorb any photons from this region. That is why it is called transparent in this region. And hence, when we place sample in the silica cells or cuvettes or sample holders, this will not interfere with the absorbance of the analyte. Therefore, it is called as quartz region. We cannot use glass or any other polymeric cells or sample holders if we want to study electronic transitions or absorption in this very region from 200 to 400 nanometer. So this was about the ultraviolet region as far as spectroscopy is concerned, and you are also classified as UVA, UVB and UVC depending upon their energy and their effect on human skin. That is more health issue rather than spectrophotometric, but we have included that just in order to have some understanding. UVC are the most dangerous or high energy radiations. Wavelength is from 100 nanometer to 280 nanometer. These are the most dangerous, and most of the UVC radiations are absorbed by the atmosphere, like ozone layer, water molecules, oxygen, carbon dioxide, etc. So they do not reach Earth. Then we have UVB radiations. Their wavelength is from 280 nanometer to 315 nanometer radiations. They are also harmful and can cause skin burns and can develop skin cancer as well. Most of these radiations are also absorbed by the atmospheric gases. Then we have UVA, a bit longer wavelength radiations in the UV region, and most of the UVA radiations are not filtered by the atmosphere, means they are not absorbed by normal atmospheric gases, and some of the flux of UVA radiations that reaches the Earth. So that was UVA, UVB and UVC classification, which is rather concerned to the health, skin health, if humans are exposed to UV